So I am Vignesh, working as an assistant professor in the Department of ECE of Kongi Engineering College. So today we are going to discuss about the topic of emitter coupled differential amplifier. So before getting into the topic, first we will understand what is a differential amplifier. So differential amplifier basically it is an electronic circuit that amplifies the difference between the two input signals, and it will reject the signal that are common to both the inputs. Most probably the noise is a common signal which can be added in all the input signals as a common signal. So this kind of circuit will uh, detect and remove those noises. Okay, so the transistorized differential amplifier basically consists of two transistors which are identical in characteristics in the sense both the transistors are made up of a same material and they are having a same cut-in voltage like that. And the RC1, the collector resistance of both the transistors RC1 and RC2, they are likely to be equal. Similarly, the emitter resistances RE1 and RE2 both are equal, and even the supply voltage VCC and VE both are equal in the magnitude. Now we'll get the emitter coupled differential amplifier whenever you connect whenever you couple both the emitter terminal together. So when we do so, the resistances RE1 and RE2 comes in parallel, and that can be replaced by the single RE uh, emitter resistance, where RE is nothing but the parallel combination of RE1 and RE2. Okay. Now we are going to study two modes of operation. Basically, one is a differential mode, another one is a common mode. So first we will study about the differential mode of operation. So in the differential mode operation, so we are going to apply two input signals. So here we are going to use a common emitter configuration. That is, we are going to apply the signal input signal in the base terminal of the transistor, and we are going to get the output at the collector terminal of the transistor, and hence this particular configuration is known as a common emitter configuration. And here I am using two transistors, namely Q1 and Q2, and output can be taken as a difference between two collector terminals, namely Q1 and Q2. So here I'm going to, since it is a differential mode of operation, I'm going to produce the differential signals, which means that the signals which are applied to the base of Q1 and base of Q2 are out of phase by 180 degree. Okay, so that is what you can see it in the diagram as well. Here you can see that uh, uh, the signal, this particular signal which is applied to the base of Q1 and this particular signal which is applied to the base of Q2 are out of phase by 180 degree. This can be achieved with the help of a center tapped transformer. So whenever you are applying any source signal, this is our input signal. So whenever you are applying such a signal to the center tap transformer, it will provide two signals which are out of phase by 180 degree. Okay, now we know that since it is a common emitter configuration, obviously this will provide the phase shift of 180 degree at the collector terminal, and it will not provide any phase shift in the emitter terminal. Okay, so whatever the signal you are applying here, you will get the 180 degree out of phase signal in the collector terminal. The same happened for the transistor Q2 as well. So here you can see that um, at the collector terminal I am having two out of phase signal, but output is a difference between these two signals. So whenever you are taking a difference between these two signals, this signal will be as it is. But what about this signal? This signal will again be inverted. In other words, it can be uh, again out of phase by 180 degree. So in such a case, now these two signals will become in phase and when we add those two signals, finally we will get the output signal like this. We'll be getting the output. Okay. For example, this is having a peak voltage of 10 volt, and this is having a peak voltage of minus 10 volt. So whenever you are subtracting these two voltages, you will be having the total voltage of 20 volt, since you are taking subtraction between these two voltage. In that way, you are getting a signal here. What happened to the emitter side? Emitter side always will be getting an input side. In the signal which are at the same phase. So the same signal will be appeared in the emitter terminal. Here also the same signal will be appeared in the emitter terminal. Finally, at the emitter terminal, these two signals will cancel because they are out of phase by 180 degrees. So they will cancel each other, and hence this particular emitter resistance will not introduce any negative feedback to this particular circuit, and hence will not be getting the reduction in the output voltage. Now we are going to study about the common mode operation. Here you are going to apply the same signal which are in phase. In the previous case, in the common differential mode operation, we have applied two out of phase signals, but here we are going to apply the same signal. That is why it is known as a common mode operation, means that we are going to apply the same signal at both the base of both the transistors. Okay, and now you can see that you are applying the same signal to the both the transistor, and since it is using a common emitter configuration, so obviously it introduces 180 degree phase shift at the collector terminal. So you can see that the signal is out of phase by 180 degree. Here also the signal is out of phase by 180 degree. At the end, since these two signals are in phase in the collector terminal, and if you are taking a difference between these two signals, you are getting a 0 volt. For example, you are and this signal is having a 10 volt of peak amplitude, and this signal also having a 10 volt of peak amplitude. Now 10 minus 10, you will be getting a 0 volt. Like that, you will be getting a 0 volt in the common mode operation. Similarly, in the emitter terminal, since will not be getting any phase shift in the emitter terminal, the same signal will be applied here. Here also will be having the same signal, and in the emitter terminal, there will not be any cancellation of signal takes place, and hence this resistance RE will introduce a negative feedback, and which will lead to the common mode reduction in the output. So in this way, we'll be having a reduction in the common mode in the output, and always this amplifier will amplify only the difference between these two signals, and always reject the common mode signal. That's it. Thank you.